Okay, so we're going on to part 2 for our 6.1, and we're going to take the greatest common factor idea one step further and factor by what we call grouping. So before we get into the actual grouping, A and B are greatest common factor problems. So what you want to do for A is you want to look at this expression as two big terms. See those two big terms? I underline them. Now for greatest common factor, we want to think to ourselves, what do these two big terms have in common? Well, you can see that they have a y minus 1 in common. And now we're going to write what's left when I factor out that y minus 1. Well, they're now gone. And what's going to be left? An x minus 13. And we have taken out the greatest common factor. Look at B over here. So it's very similar. So we're going to look at this as two big terms. Let me point out what is the number in front of this set of parentheses. It's actually a -1. We're going to need that. So what do these two big terms have in common? Well, they have a 2m minus n or plus n in common. We're going to factor that out. It's now gone. And what is going to be left? Well, what's going to be left in this first term is 5x squared y cubed. And in the second term, we'll simply have the -1. Okay, so now let's take both of those concepts we just covered, the greatest common factor and this, and let's put it into a grouping factoring problem. So first of all, the type of factoring that you will use is always dependent on how many terms you are factoring, whether it's a binomial or a trinomial, or if you have a polynomial of more than 3 terms. Okay, the first type of factoring you will always do, no matter how many terms you are looking at, is you will always take out a greatest common factor first for all of the terms. Always, always, always. Once you've done that, then you can go ahead and count the terms and decide what's my next step in my factoring process. So if we look at C, do you notice that all 4 of them don't have anything in common? It would have to be common to all 4 of them. There's nothing. Whenever you have more than 3 terms in a polynomial, you are going to factor by grouping. 98% of the time, you will group them in this manner. You will group them 2 and 2. Now, notice how I kept this positive sign inside my second group of 2, because remember, we always want to try to think of the sign before the term as the sign of the term. Try not to think of this as a plus. Try to think of this as a positive AY. Okay, so now that we've grouped them 2 and 2, we go here to my first group of 2 and we take out the greatest common factor. What do these two terms have in common? Well, they have an x. And now what's going to be left when I factor out the x? Well, I'm going to have an a plus a b. I go to the second group of 2 and I do the same thing. Well, what do they have in common? They have a y. And in fact, they have a positive y in common. So we take out a positive y, make sure that that symbol is there. Sometimes you're going to want to take out a negative, and then that would be a negative. And what's left when we take out a positive y? Well, you can see we have a plus b. Now, if the polynomial factors by grouping, what has to happen is what's inside the parentheses has to be the same. If it is not the same, then it does not factor by grouping. Okay, so now we're back to where we were in 4a and b. Think of this as 2 big terms. What do those 2 big terms have in common that we can factor out as a GCF? They have the a plus b in common. Those are now gone. What is left? We'll have the x plus y. So if I were to FOIL these 2 binomials out, and notice it's 2 binomials, so I'd have to FOIL, I would end up with this polynomial. Okay, We're going to do that 4 more times here. Now, everyone's going to have a little bit of a tweak we might have to do. So, for example, if I look at D, do you see, well, there's no GCF for all of the terms. You can see that. Do you also see that if I were to group these two first terms together, there would be no greatest common factor, would there? There's nothing that divides into both 7x and y squared, so that's a problem. So sometimes if you notice something like that, you may have to rearrange the terms. And there are going to be a couple of different ways that you can rearrange the terms and get the same answer. What I'm going to do here is I'm going to put my y squared first, then I'm going to put my negative 7y. So I'm going to combine these, and then I'm going to put the plus 7x and minus xy. So I just rearranged the terms, use my commutative property. Now let's go ahead and group them 2 and 2. So let's see. Those have a y in common. I'm going to take out a y, which leaves me with y minus 7. Now, remember what I said earlier. When I take a GCF out of this, the second set, I also need to have a positive y minus 7. Do you notice, first of all, they have an x in common, but if I were to take out an x, I'm going to have 7 minus y. I don't want that. I want it flipped. So what I have to do is I have to take out a negative x. Let's see what that does for me. 7x divided by negative 1x is going to give me a negative 7. And negative xy divided by negative x is going to give me a positive y. Look what's inside the parentheses now. Those are the same. You have a positive y and a negative 7. Yes, this one is flipped, but that's okay. So now let's go to the last step and let's look at these. What do these two big terms have in common? Well, they have that y minus 7 in common. That's this, so those are gone. And what's going to be left? A y minus x. So that had 2 tricks to it. You had to rearrange and you had to factor out a negative. Okay, let's play with factoring out that negative a little bit more. Let's look at E. So you notice that there's nothing common in all 4 terms. You should always check that first. Let's group them 2 and 2. Well, if I group this first 2 together, you can see that they do have something in common. So I can leave it in this order. Notice how I'm keeping this negative in here. So it's a negative CD. So let's take a GCF out of my first group. You can see I'm going to have a 2 that comes out, leaving me with C plus D. Remembering that I need a positive C and a positive D left when I factor a greatest common factor out of here, it should be obvious to you that you're going to have to factor out a negative to change the signs. And what do these 2 terms have in common? They have a negative D. Now what's going to be left? So a negative divided by negative is positive. The D's are gone, so it's going to be a positive C. Here, negative divided by negative is again positive, and D squared divided by D is D. And we end up with the same thing inside the parentheses. So now just really quickly, finish it off. So if we think of this as 2 big terms, they have a C plus D in common, which will leave me, when those are gone, with a 2 minus D. Why don't you go ahead and try F on your own and then come back? So pause the video, try it on your own, and then come back and watch me do it and see if we get the same answer. Okay, so as I look at this, I notice that they have a 5 in common. Remember, always check for that GCF first. Do you see that 5 is divisible into all 4 terms? So we are going to take that out. As I look, none of the variables are the same though. So if I take out a 5, that's going to leave me with 3xz plus 3yz minus xy minus y squared. So now I'm going to use my grouping on this set of 4 terms. So again, I'm going to group them 2 and 2. I'm going to ignore that 5 for a minute, but I'm not going to forget to bring it down into my answer, so don't let me forget. So if I look at this first group of 2, what do they have in common that I can factor out as a GCF? Well, they have a 3z in common, so I'm going to be taking out a 3z, which leaves me with x plus y. Let's look at this second group of 2. Hopefully it's obvious to you that we're going to have to take out a negative. And it looks like they have a negative y in common, which is going to leave me with, if I divide, I'm going to get positive x and positive y. So now again, looking at this as 2 big terms, what do they have in common? We're going to factor out the x plus y that they have in common, which will leave me with 3z minus y. And don't forget to bring the 5 down as part of our answer. Now for G, you're going to want to rearrange. So I would pause the video again, rearrange for G. Actually, now that I look at it, you don't have to rearrange if you don't want. I'm going to rearrange, just an FYI, but you don't have to. Go for it. Go ahead and do G and see what you come up with. Okay, so I'm going to arrange it in descending order of the exponents. Again, as I said earlier, you don't have to, but it just makes me feel a little bit more comfortable, so I'm going to go ahead and I'm going to do that. So I'm going to group them 2 and 2. What comes out of this first group? An x squared, which is going to leave me with x minus 3. And what's going to come out of this second group is going to be a 2, and that leaves me with x minus 1. Are these the same? Can I make them the same? No way. So this is not factorable. We call that prime. And there's the end of these notes.